Yeah. I guess there aren't too many important announcements except exam tomorrow in class, in person. So please be here for exam unless you've made arrangements with me because of external conflicts. I talked to the TA and he still feels like utter garbage, but he says he is gonna work his tail off to get homeworks 1 and 2 turned around by today. So I don't know how helpful that is to not really be able to do a bunch of back and forth with me about how the homework went and what you could have done about that, but it's better than nothing. Again, I realize how unfortunate that is, and I'm making a note of it and being aware of it moving forward for things like how much extra credit I give on future exams, or to the extent to which I curve final grades at the end of the quarter. Data like this is something that I take in and just make sure that it's not held against you for something that was out of your control. That said, hopefully you get that feedback tonight and it's useful. Homework 3 is also being revealed today, but one thing to note, I'm in the process of restructuring the amount and size of the homeworks because historically these homeworks have been a little bit on a large size. And the first couple of homeworks that you've had have been the historical first 2 of 6 assignments. But I'm going to start breaking the assignments down into smaller weekly pieces, which means that normally you wouldn't have an assignment this week, but instead you're going to have a smaller assignment and it's going to say homework 4, because in the future, the 2 homeworks that you've had so far will have been split into 3 homeworks. So don't pay any note to the fact that the next homework you see says homework 4. It is our homework 3, and the future is homework 4. All right, I want to spend the rest of the class period as much as possible answering your questions, and I have quite a few practice problems that can easily take the entire class period, probably more than that. So I'll upload these slides right after class so that you can work on whatever we don't get to or whatever you want to circle back to for practice. But are there any questions that I can answer directly off the study guide? Like clarification questions on anything from the study guide before we dive into actual practice? And you can also ask those as we're doing the practice. It's not like this is your one shot. If you don't ask it right now, then too bad. But anything I can answer straight away? Clarification, not practice. All right, so I have 4 different classes of problems that we can work on. I have NFA to DFA conversion, DFA minimization, regular expressions, and grammars. Is there a preference for where we start between those 4? What would be most useful practice to start with? NFA to DFA for a vote?
For regular expression.
Regular expressions, grammars.
Expressions, grammars, and then.
Okay, so regular expressions and then grammars and then NFA to DFA. I can do that. I think that makes sense. All right. Here are some practice problems. 5 regular expressions. Look at these, and if you have an intuitive idea of how to start one, maybe start with the ones that are less intuitive to you. And I can go over as many of these as we want, any or all of these, depending on what we think would be useful. Good intuition check for people. If you're starting with 7, the first problem here, my recommendation is you should probably be done already. It is fairly similar to a couple of regular expressions we've seen before, both in class and on the homeworks. So if that makes sense to you, then applying it to 7 should be fairly straightforward. That said, 8 is not quite as similar. I anticipate that one might take a little bit longer. And 19A is not too bad. 19B is a good bit harder, and 19C is disgusting. Probably more than I'd want to throw in an exam, but it's a good way to see how intuitive this is to you if you can break it apart and see a solution for it. We have a solution for 7. What do we have?
I just did 3 A's for the 4th A to have a start world.
Yeah, so in order to get the greater than or equal to 3, we need to guarantee the 3, A. Then any optional number of A's after that.
We can add the Z's in parentheses. And
Yeah,
next
after that we have at least 1 B.
then I think we can make that be an optional 2 B's.
Yeah.
Solution.
Yeah. So this guarantees an odd number of B's. We see a single B. We know that has to be the case in order for it to be odd. And in order to get to the next odd, we need to see pairs of B's from there. And we have the order embedded in this. The A's come before the B's, so we don't need to worry about order. So it flows together fairly straightforward, fairly easily. There's not too much thinking to do outside of just looking at the structure and saying, how does this relate to how we've thrown together similar expressions before? So stuff like this has been on the homework, so hopefully you feel practiced at something like this. How do you feel about 8? 8's a little bit harder. I don't want to spend a ton of time on the rest of these, but I'm hoping that you're focusing on and prioritizing the ones that will be challenging for you, or that you look at this and say, how would I tackle this on an exam? Thoughts on 8?
I was thinking, because you could have either even A's and odd B's or odd A's and B's.
Mhm.
So you could do A star, B star, or A star,
Yeah.
B star.
Okay, I like that. There's a slight simplification we can make to that, but that will work. So basically, we want to make sure that the sum is odd. So whatever A's we see come in pairs at the beginning. So we can say AA star. And what we know ends this is BB star. And then we need something that makes this odd. So there needs to be a character in the middle of this that is either an A or a B that forces this to have an odd number of characters. So we can just throw that in the middle and say one of either an A or a B is that middle character that makes it odd. And again, we can do this because all of the A's have to come before all of the B's, so we don't have to worry about the order of A's and B's. But you can absolutely distribute this A or B and turn this into two different expressions, one of which has an A and one of which has a B. Questions on that solution? How you might intuit that solution from looking at this? All right, let's take another minute or so and finish up whatever we want to in 19 before I can at least explain some of the reasoning behind it so that we can move on to a couple of other topics. Great. What do we have?
Actually, no, B and C star. With an A after that. Then that B and C star would be taken. It's another A. Finding B and C star.
That'll do it. I like that solution a lot. So we force the two A's, what comes before the first A? Who knows how many B's and or C's? Between the two A's, any number of B's and or C's. After the last A, some number of B's and or C's. Fairly straightforward. I would not feel bad throwing any of these three on an exam. B and C, I feel like B is within the realm of difficulty, but it's long enough that I wouldn't want to force someone to write this much on an exam, given the difficulty of the problem. So this would probably get cut, not because it is too difficult, but because it would take too long to write. Which means the expression is long, it's just not that complicated. C is long and complicated.
Isn't this one like the same as A? B is the same as A, except now we're saying A or lambda.
Basically, this is exactly 2, and no more than 3 is 0 or 1 or 2 or 3. So you want to split those apart into exactly those cases.
But doesn't saying A or lambda on both? If you have that as a group A or lambda instead of the A.
And then you would add one more of those groups to
Right.
that.
Okay, interesting. So you'd say we can either have the A or not have the A, and it's optional where those A's appear.
Yes.
I like that. I think that's a perfectly reasonable solution. So turn this into an A or lambda. Turn this into an A or lambda. And then take that chunk and repeat that one more time.
Yes.
Yeah.
That's what I got.
I think that does it.
Is there a better way?
There's a longer way. That was what originally came to my mind, but I think this works and it's a lot more efficient and better. So I'm perfectly happy with that. I wouldn't hate throwing this idea on an exam, but I also try where possible to not have it be where you can interpret it to be super long and then write out the super long. Here are all the ways you can have 0 A's, all the ways you can have 1 A, all the ways you can have 2 A's. But I don't know if there is a better way for C than something that is absolutely disgusting. But what is the intuition? Because I think that's what serves you well on an exam is the ability to look at this and go, I know how to solve this. I know what I would do to solve this. Yeah.
As an idea that I had, it would be in parentheses, A or B or C, star, A, and then A or B or C star, B, A or B or C star, C, A or B or C star, and then just add another or at the end with different combinations. of A, B, or
Yes,
C.
that's what makes it so annoying is you have to work with every single possible combination of where that guaranteed occurrence comes in.
I was afraid that might be correct.
Yeah, that is exactly what we have to do. So how many combinations when we have 3 characters?
8.
That would be if we allowed for repetition. So we'd have ABC, ACB. We don't allow for repetition. Those are the only 2 ways that an A can start. And then you just multiply that times every character that could start. So times 3 gives us 6. So there would be 6 possible combinations of the order of the occurrence of each of those symbols. And for each one, yeah, we have to have an arbitrary number of any symbol that could occur before the guaranteed first symbol. Any symbol that could come between that and the second symbol, then the second symbol, and anything that could become between that and the third symbol, then anything that can come after the third symbol. Or that for every single combination of each of the first, second, and third symbols. So it's really long and gross. And I would not be happy throwing that in an exam. That said, I am okay with the assumption that you can figure out how to solve that problem. And maybe describe how to solve that problem. But I would not make you write all of that out. We only have an hour for the exam. I don't want you to spend 10 minutes writing a solution that it didn't take you that long to come up with. The thinking to writing ratio is something that I care about on an exam. I want there to be more thinking and less just unnecessary writing. Questions on any of these or how to intuit some of the solutions to these? Right, due to limited time, I would have loved to give people more time to work on those, but there's lots to review. All right, here are some grammar problems. Way too many to go over in class. I just decided to take a chunk of the book's practice problems and throw them on here. This is brand new to me. I have never seen any of these problems before, so I'm working off the complete top of my head, just like you all are for any of these. So find a couple of them that look like good practice problems for you, and then I will query the class for which ones you'd like me to go over. And we'll find a solution together. It's kind of small. I can zoom in. It's a little bit great.
Which problems are we doing?
Any of them that look like good practice problems to you.
Okay.
And as you either come up with a solution you'd like me to verify, I can attempt to go verify it, see if I can find an issue with it. Or I can, if you find one that you're struggling with, then we can intuit a solution together. I didn't get a chance to look at these and say, this would be the one good practice problem. I also wanted to throw a good bit extra on there in case you wanted to go home and practice some more.
Can we go over the A17As?
Yeah. Yeah, I like this one. So what we see here is that we have 0 or more A's followed by some number of B's that is less than the number of A's, which is strange to me because you could really say that n is greater than or equal to 1 in that case, because if n is 0, there's no value of m that could be strictly less than that. That's the first thing that pops out to me, is that we do in fact need at least one A. So to me, this says we should have a start non-terminal. We want to produce that first A immediately because we know there's at least one of those. And then we should be able to produce either pairs of A's and B's or A's. Does that make sense as to how that gets there?
Pairs, just like.
Yeah, so we're actually going to recurse in the middle of this. So our point of recursion is always going to be in the middle between the A's and B's. Whenever we have the A's, they're going to be on the left side of the recursion. Whenever we have the B's, they're going to be on the right side of the recursion. So we're going to produce the first A, and since we want to recurse in the middle of the A's and B's, the immediate recursion should be after that. So the A is on the left. Then we need the ability to produce an A and a B. So we can go back to the start to do this. Or we need the ability to produce an extra B. Or the ability to terminate. So I think that does it.
And you then have more B's.
More B's than A. It needs more A's than B's, doesn't it? So we need the ability to produce more A's. That. It's not a good A. Yeah. That's what I meant.
I created.
Yeah.
I don't know if it works the way I did it. I did it where like S goes to capital A. And then A can be lowercase a, capital A version. Or be A, capital B. Oh,
Lowercase a, capital B.
The B can either be another A, lowercase B. Or it can be lowercase a, lowercase b, capital B, so recursion.
I feel like this allows A, B going back to A from this B. So it doesn't guarantee that all the A's come before all the B's. There's a path through that that allows for that. And in this case, we actually don't know how many A's that we made when we do this. We need some way of keeping track of the difference between the A's and the B's in a way that I think this in general allows us to say that they can come in pairs. For every B, there has to be an associated A, but we can always make A's for free. But every B that we make needs to have an associated A. And that guarantees, since we did this at the beginning, that there is that at least one extra A, so that it's strictly greater than the number of A's is strictly greater than the number of B's. But we can produce an arbitrary more A's than B's by selecting this the appropriate number of times for more A's than B's. And there's no way to produce B's without A's in a way that keeps them consistent. Yeah.
Do you want specific other solution wouldn't work? So for example,
Yeah, this solution.
a different one. So S goes to A S B.
A, S, B. So we're going to produce the same number of A's and B's. Yep.
And just do S goes to A.
Or like a lowercase a.
So
That would allow for exactly one more A than B, but not 2 more A's than B's or 3 more A's than B's. So we could do something like this, where we allow the recursion to produce an arbitrary more A's, but now we need the ability to guarantee that there's an extra A. So I guess we could do that for the last possible A, and does that work? This might work.
The one I had was S goes to capital A, capital B. A goes to capital A. A goes to capital A, lowercase a, or lowercase a. B goes to capital B, lowercase b, or lambda.
So this forces, whenever we have this, we know that there's going to be some number of A's, some number of B's that get picked before lambda. I would argue that it's possible with this, it's very close. You can go S arrow A, B, this A goes directly to the A. And this B can now go to the BB an arbitrary number of times to create more B's than A's. But it's really close. We need some way of looping back on this to S in a way that forces this to be at least 1A and forces a little bit more than very close. I think there's a way to make this idea work. Not right off the top of my head, but if given a minute, I could probably force this to work. It's close though. So questions on A? I think that was a very good practice problem. This is what immediately occurred to me, but I think this might be the best solution. After thinking about it for a second, walking through it with this, I think this works. Pairs of A's and B's, only A's in the appropriate order before the S, and terminating with the guaranteed extra A that has to be there. So my way of thinking was starting with that extra A and forcing that extra A to come first, but we can force that to happen on termination as what terminates this recursion. And we're always recursing after the A's and before the B's, so there's no way to mess with the order. Thoughts or questions on A? I want to take a second and talk about G, just because it's incredibly related. There's a trick that we can use to make G very easy. Does anyone know what they would do to solve G given a solution to A? So if we either had this solution or this solution, what could we do with that solution to solve G?
Add the production SSS.
Yeah. So we would have something like S1 arrow SSS. And that's our new start non-terminal. And now we can directly produce 3 consecutive any possible solutions to the old problem. So this is the equivalent of concatenating that language together 3 times. And you can do exactly the same thing here, S1 arrow SSS, and done. So that's true, given any solution, you can concatenate that language together an arbitrary number of times by just making a new start non-terminal and putting the old start non-terminal on the right-hand side that many times.
G allow for A's and B's to be multi-different?
Yes. Yeah. So you'd have something from this solution, followed by something from this solution, followed by something from this solution. So we just have that production that says, however we generated the first part with those rules, that's what comes first. However we generated the second part, that's what comes second. Yep. Is there another one we want to go over besides A? Is anyone working on something else? Or see one where you don't really know how you would start the problem and want to see some intuition for how to think about the problem? H.
I just have a question on E.
Yeah.
When it says L1, L2, does that mean like L1 and L2, so only streams accepted by both?
It's the concatenation. So you have the left-hand side coming from L1, the right-hand side coming from L2. So L1 star says 0 or more repetitions of this. How could we allow for 0 or more repetitions of something we already had a solution for? Yeah, so we need some ability to recurse and have the ability to make more of these. So two things that we need to add to this, since we already modified this, I'll modify this, but the same thing would work between any solution. We need the ability to immediately go to lambda to have 0 repetitions of it. And we also need the ability to repeat it an arbitrary number of times. And this is what would allow for that. If S goes to SS, how many times do we pick that? That will add an extra one, add an extra one, add an extra one, add an extra one. So the idea is you pick this enough times to create enough S's in a row for the number of repetitions of L1 that we care about. Once we have enough of those repetitions, we go through the process of guaranteeing an A and then moving through with the solution to that. So that's good. Anything else we want some intuition for?
So maybe like the complement, but in order to do that, we need to do L4.
Yeah, we would need to have a solution for L4. Any quick ideas for how we would do L4, even without drawing it out? Just what's the intuition for solving L4?
For the first one, we can define A to be, it can repeat, but in the first S definition, we would want A, capital.
Yeah, we know there's at least 3 A's and 1 B.
Yeah,
So we can immediately do that. S arrow A, some recursion B, because we know that's the case. And now we have the difference, so we just want to produce arbitrary more A's and B's. So I would say just go to the next non-terminal at that point and have that either go to produce an A and a B and recurse, or do nothing. That's my solution to L4. In general, with grammars, the general piece of advice, what is constant? We know that when we analyze this problem, some n A's followed by n minus 2 B's, we know immediately there's at least 3 A's and at least 1 B, and there are 2 more A's than B's. That is something that is for sure doesn't depend on the value of n. So you can factor that out and immediately put that in your initial production. Then what is your variable? The variable is the number of extra pairs of A's and B's past that base case 3 A's, 1 B. If you think about it like recursion, you're defining your base case here, you're defining your recursive case here. It fits with something you've seen before and allows for a general way of looking at these problems that allow you the intuition to quickly come up with a solution. Yeah.
Like 18 something cents.
That's probably not too bad. So there are going to be groups of 3. We need the ability to solve for the base case of the mod. So we are going to accept for something like B, start with 2 guaranteed, because that is the smallest mod 3 that we know for sure. And then everything after that has to come in triples of A's. So as simple as we could make that would be S arrow S or AA.
Oh.
If we go straight to here, we have 2, which is the smallest mod 3 equals 2. If we add 3 to that, 5 mod 3 is 2, 8 mod 3 is 2, 11 mod 3 is 2. So again, we have the base case and the recursive case.
can we do I the complement of,
Yeah. So anything that's not accepted by that, that's definitely the challenge problem here. I don't think I would love throwing that on an exam. solely because just thinking about what is the complement of L4, how do we come up with something that's not accepted by this? That's more of a homework problem than an exam problem to me. We could go through that solution, I think, if we had more time.
Yeah, that's.
But I want to dedicate the last 10 minutes to the other couple of ideas that we have.
I was worried it would become an exam.
Yeah. I also understand that that's the one that's not as easy to see intuitively, that you might need a little bit of time to work through. Yeah, I would not want to throw that on the exam. Too much work. We have too many things to cover. Maybe if it were a one-question exam, but I also don't like doing that. Questions on grammars in general while we move on to the next topic? Okay. Let's do that real quick. NFA to DFA conversion. Here's the NFA converted into a DFA. How are we doing? We get there? Looks like some people might have gotten there. Who wants a little more time to work? Yeah, I'll give you another minute or two before we go over the solution. If you're still working, don't look at the board. If you'd like to check your answer, here's an answer.
I also wanted to ask, are we gonna be asked about regular, so like right linear and left linear grammars as well on the exam?
No,
No,
that'll be the very first thing on the next exam.
okay,
Although there may or may not be an extra credit question on a grammar that says if you could solve this as a regular grammar, then I'll give you extra credit.
okay.
So it is regular, but you have the power to solve it however you want if you can solve it in a left linear or right linear fashion.
I don't remember, is every grammar able to be solved in a left linear or right?
No,
No, okay, good to know.
a lot of the grammars that we just focused on could not.
Okay.
It needed that recursion in the middle. As soon as we need that recursion in the middle, we can't have recursion on either end. Good question. How do we feel about the solution? Is this what you got or close to what you got? All right. With the last couple of minutes then, I at least want to give you the chance to write down some of these and or start working on them. These are the DFA minimization questions. I had identified B and E as the most interesting ones because they are the union that we are used to drawing NFAs for. So we know that all NFAs can be converted into DFAs, but finding a DFA for something that's easier to solve with an NFA is kind of a fun exercise. It may lead you to make DFAs that aren't quite as minimal, and you may actually find that you have some indistinguishable states in your solutions.
So will these be posted?
Yeah.
Okay.
I have to make sure I give you the most recent version though, because I added the grammars this time. I added them this morning. I'm also happy to go over any of these or to go to help you work through some of these during office hours. It'll start right after class. Yeah.
So if we're doing like the union for these, then we make the
Never mind, sorry.
I was thinking about it.
Yeah, the NFAs are fairly easy to construct. If you go through the NFA for these and then you do the NFA to DFA conversion process and then try to show that that's minimal, it might not be minimal. It's just guaranteed to be a conversion. So maybe that's the process that makes the most sense for you. If you see this as an NFA problem, how I would do this at home, if I am one of you, is to make an NFA, go through the NFA to DFA conversion process, and then do a DFA minimization, because you may end up with those indistinguishable states in ways that actually forces me to prove that I know how to do that.
So then if I make that NFA for that, would I just have from Q0 two different branches?
Yep.
Like with the same?
For B, not necessarily, because you force the A versus the B. To start. Yeah, if you're looking at E, then yes, you'd have two separate A's out of the initial state, which would be something we can't do with a DFA. So we'd have to alleviate that with the NFA to DFA conversion process. Kind of seeing how it all flows together. Idea that's easier to solve with an NFA, convert it to a DFA, make sure the DFA that you find is minimal. All right, it is time for us to get out of here. So I'll upload these slides. If you want to work on it in the immediate term, make sure you've written down a problem for you to work on. I'll try to get these up in the next hour, as soon as I have a spare moment in office hours. Hopefully I see a good chunk of you in those office hours. Possibly see you soon. Possibly see you tomorrow. Yeah, definitely see you tomorrow. Please don't miss tomorrow.